So today in this video we will be covering these objectives. 2.5 of the Cisco exam objectives, which is interpret basic operations of rapid PVST plus spanning tree protocol. 2.5a, which is root port, root bridge, primary and secondary, and the other port names. 2.5b, port states, forwarding and blocking. 2.5c, port fast. So let's get into this. Configuring VLANs that span multiple switches. Rapid per VLAN spanning tree plus, or rapid PVST plus, is an enhancement of the spanning tree protocol, or STP, used in network switches to prevent loops and ensure a loop-free topology. Here's an overview of its basic operations. So here's the overview. Spanning tree protocol overview, bridge protocol data units, or BPDUs, root bridge election, rapid convergence, port roles and states, and topology changes, and per VLAN operation. So let's cover each by each. Start off with spanning tree protocol overview. STP is designed to prevent network loops by creating a spanning tree that selectively blocks redundant paths in a network. PVST plus per VLAN spanning tree creates a separate spanning tree instance for each VLAN, optimizing traffic flow. Rapid PVST plus enhances this by incorporating the rapid convergence benefits of Rapid Spanning Tree Protocol, or RSTP. Bridge protocol data units, or BPDUs. The switch with the lowest bridge ID, composed of priority and MAC address, is elected as the root bridge for the spanning tree. Each VLAN has its own root bridge. Port roles and states. Each port in a rapid PVST plus network has a specific role and state. Roles are root port, which is RP, the port with the best path to the root bridge, designated port, or DP, the port on a network segment that has the best path to the root bridge, alternate port, AP, a backup port to the root port, BP, or backup port, a backup to the designated port on the same switch. The states are discarding, which is when the port is not participating in the frame forwarding. Learning, the port is where it's learning the MAC addresses but it's not forwarding the frames. And forwarding, where it's actively forwarding the frames. Rapid convergence. Rapid PVST plus improves conversion time over traditional STP. This is achieved through proposal and agreement mechanism, where it quickly transitions ports to the forwarding state by negotiating with directly connected switches. This is also known as port fast. Port fast is where it quickly transitions into forward state, basically skipping the check sequence. Edge ports, ports connected to end devices rather than other switches, can be immediately transitioned to the forwarding state using port fast feature. Link type, ports can be designated as point-to-point or shared point-to-point. Links can immediately transition to forwarding state when the connection is established. When a topology change occurs, such as a link failure, Rapid PVST plus quickly recalculates the spanning tree. This involves topology change notification. When a switch detects a change, it sends it's a BPDU to the root bridge, which then propagates the change throughout the network. A BPDU is a bridge packet data unit. It is basically an indication that a switch will send to basically tell other switches, hey, I'm still active, I'm still here. And BPDUs just send each other every single 10 seconds. So this one, in a case where the topology changes, it sends a topology change network BPDU to the root bridge, which propagates the change throughout the network. Flushing MAC addresses, or MAC tables. Affected switches flush their MAC address tables to ensure stale entries are removed, facilitating quick reconvergence. So per VLAN operation, it's when each VLAN runs its own instance of Rapid PVST plus, allowing for VLAN-specific optimization. This ensures that the changes in one VLAN topology do not affect the other VLANs, enhancing network stability and performance. So, let's go over the summary. Basically, Rapid PVST Plus offers enhanced network loop prevention and faster convergence times compared to traditional STP. By using separate spanning tree instances for each VLAN and leveraging rapid convergence techniques, it ensures efficient and resilient network operations. The root bridge, the central reference point in the spanning tree topology. All switches calculate their best path to the root bridge. The root bridge is selected based on the lowest bridge ID, which is a combination of the bridge priority and MAC address. Each VLAN has its own root bridge in Rapid PVST+. The root port. This is the port on a non-root switch with the lowest cost path to the root bridge. Each switch except the root bridge has one root port. It forwards traffic towards the root bridge. Other port names are these, where it's designated port, which each segment has one designated port responsible for forwarding traffic to and from that segment. An alternate port, where it's a backup to the root port. If the root port fails, it becomes active. And then a backup port, which is a backup to the designated port on the same switch. It provides redundancy on a shared segment. Port state, or forwarding and blocking. These are discarding and blocking, where the port is not forwarding frames to prevent loops. It does not participate in frame forwarding, but it can still process the BPDUs. This is the initial state. Learning is where it's not forwarding, but it's learning the MAC addresses from incoming frames to build its MAC address table. And forwarding, the port is actively forwarding frames and learning MAC addresses. It participates fully in the network topology. Port fast. Port fast is a feature used on ports connected to end devices, such as workstations, servers, or printers, rather than other switches. So when port fast is enabled on a port, the port skips the usual STP listening and learning states and transitions directly to a forwarding state. This significantly reduces the time it takes for a port to start forwarding traffic, providing a quicker network connection for end devices. Advantages to port fast are reduced delay. End devices can start communicating immediately upon connection, improving user experience, and stability for end devices, which prevents temporary network outages for end devices when they're first connected or when a computer reboots. Important considerations are loop prevention. Port fast should only be enabled on ports connected to end devices. If enabled on a port connected to another switch, it can cause network loops, which is why I don't recommend it on anything where it's connected between switches, because network loops are bad. And port fast should be only connected to the ports connected to end devices. BPDU guard is recommended to enable BPDU guard on port fast enabled ports to protect against accidental connections to another switch. BPDU guard disables the port if it receives a BPDU, preventing potential loops. In summary, understanding these components and features of Rapid PVST Plus helps in designing a robust and efficient network topology, ensuring rapid convergence, preventing loops, and optimizing performance for end devices. Thanks for watching. If you want to support this channel, subscribe, like, and comment. And thank you so much for watching. Have a great day.